The first thing that we looked at was what are the things that we require when we select a rig. So one is we have to look at the maximum load that you're planning to use, or what is the deepest casing that you will run. And always keep in mind that you have a safety margin. Even if it's about 20 to 30%, it is fine, but that safety margin will help to take care of things. Like this will not happen on your rig if you have the safety margin taken into consideration. Now, the next one is the most important other part is the drilling fluids. Go ahead.
One thing, when you're looking at the maximum draw capability of the rig and the weight, et cetera, remember you have a severe penalty when you do deviated drilling. You cannot go nearly as deep as you can vertically with the same rig because you have a friction factor on all that, the drill pipe and things are coming out of the hole. So that was one of the issues with Aluto, is that we really couldn't drill as deep as we would have wanted to do because of the size of the rig and because we wanted to drill deviated wells.
So just to touch upon what Gordon was talking about, if you think of this as the top of your well and drilling straight, the load on the string is considerably less, or is a natural load. Or you say if the weight of the string is 100 pounds, I can see 100 pounds on the hook. But the moment you think of deviation, now what is deviation meaning? Does everybody understand what's deviation? If in simple terms is I can go from here straight down, or I can go from here and reach here. So this is what is called directional, where you're coming this way. Why do you do that? There are some reasons. Sometimes getting here, there may be a hill. So rather than on a flat surface, I can set a rig and come directional. But here you have to make sure that when you're doing directional, if a hook was hanging like this, it is 100. But when I'm drilling directional, when I'm trying to pull it out, there is a lot more of drag along this as I pull it out. So rather than being only 100, it may be 125. So that means when you're looking at a safety factor, you have to add that 25 to that first and then add your safety factor. Are you all with me on that? This is quite, nowadays we have to always consider this because many of the wells that we drill in geothermal are now going not horizontal, but about 30 degrees angle is normally what we use. So that also helps to save on cost of the pad, so that you're sitting on the same pad, one you're going here, one you're going straight.
Actually, I saw one pad that had 10 wells on it, each going in different directions.
Now here you see the next most important thing when you're drilling. You use fluids for actually, there are different things that does. It cools the bit, it helps to bring the cuttings to surface and things like that. So when you're planning that, you make sure that you have the right amount of, these are your pit systems that you're seeing. So you should think of how much of volume do I need. Then it also has, sometimes if the well gets very hot, you have to cool the well. Or if the well kicks, you need to quench the well. So those are things that you have to take into consideration when you're planning your water or your fluid systems. Now, just a quick one here is, when you think of suitability of an equipment, I would say the best standard to use, which is internationally accepted, is the API. That's an American Petroleum Institute. They give you very strict standards, and you can follow that. Next is, when you have different structures on the rig. You've got the mast, you've got the pipe. Everything has to be periodically inspected. Now sometimes you do it after every well is completed. It is sometimes costly, but what does it save you? I'll give you an example. That's why we are saying, if you read there, periodically fatigue and corrosion. Because many a times, something looks very nice like this, but when you are looking at a metal with a closer inspection, you find that there are already cracks in this metal. It will not show up on the surface very easily. Once you do that, what happens is, and that's why I gave you the example of a pipe of water. Even if there's the smallest leak, because you're pumping with pressure inside this pipe, that leak can break out. And then we call something called a fish in the hole. What do you call a fish in the hole? Is, now this is the piece of pipe I'm drilling, and as I was drilling, part of this fell off. So now I've got this piece of the pipe has fallen in the hole. I'm sitting on surface, this is the other piece of the pipe. Can I drill any further? No. This is a fish. Until I do not get this thing out, I cannot continue drilling. How do I fish it? Right. Yes. And I think so I have added it somewhere there. But one of the things is, let me tell you, is a very standard procedure is, even when you're contracting, make sure that, or when you're starting drilling, anything that you put in the hole, you should have a tool to be able to pull it out. If you do not have that, please do not put that tool in the hole. Am I clear? Anything that you are running in the hole, make sure you've got a piece to pull it out. If not, please do not run the hole.
You know, so this is one of the reasons that Sam was talking earlier about having every team member as part of the discussion. Because it's as important to talk to the warehousemen and the inventory people as it is to talk to anybody else. They are going to be sending the equipment out to the rig from the warehouse. Somebody's going to have to record every piece of equipment. They're going to have to know every piece of equipment that goes down hole. And when it comes back out and it's used, they need to then calculate how well that piece of equipment has worked, so that they know that if they're going to order something in the future, either this is a good piece of equipment or it's not a good piece of equipment. All of this goes into your well logs and your well data collection, so that the next time you're going to plan a well, you say, well, gee, these 4 bits that we used for this, we thought would be great. They didn't work at all. We need to replace them with something else. And when it comes to, corrosion, you may have read recently about a terrible plane accident in the United States where an engine actually just exploded. It came apart. That was from fatigue corrosion in the engine. And it basically cut a woman in half. And it was just one of these terrible things that it was an older aircraft, hadn't been properly maintained, and some of these things are almost impossible to detect unless you actually use X-ray or something else for detection.
Now, if you see on this one, I've left something. Yes, go ahead. Uh-huh. Yes. Any equipment, always, whenever a manufacturer makes an equipment, they will always make an equipment to be able to fish it. That is standard operating procedure. But let me tell you this, any equipment that you make, for example, as simple as that, any truck, car, or bolt on your truck will have an equipment to open it, right? Same thing, any equipment that you put in the hole, you can always go to a fishing tool manufacturer and he will make you a fishing tool to fish that out.
That is the case in solution mining cover, so the velocity on the cover.
Yes. Now there also, sometimes the thing is, I have come to a picture later, we call it, I'll not go there now, something we call is fishing. Fishing, the moment you drop that, if you have the tool, you can go quickly and fish it. If it sits there for 2 days, it's history. We call it fish grows roots. Quicker you have the equipment, that's again why we say backup of a backup, is where will you get a fishing tool in Ethiopia from? Nothing available, you'll have to go to Dubai. So that is why before you plan the drilling operation, you should have the fishing tools here, so that one fishing tool, a set of fishing tools cost you $50,000 a monthly rent. But what it saves you is 1 day of drilling also. And that's 100,000 saved. That's why we talk of that one. Now, yeah.
Geologically, there are a lot of complications under the ground. So
Yes.
how this 100 to
Uh-huh.
How I can get be sure?
You can almost be, say, 90% sure. Some of 10% is still a problem, but first thing is, do you have the tool to fish it? Okay. The second thing is, Gordon touched upon one thing. Many a times when you run the tool in the hole, you do not take the size of that tool. You just run it in the hole. So now when you have to go and fish it, you do not know what you're going to fish. Got it? So those things, if you take everything into consideration, you've got the right tool to fish the equipment, you can do it. But if you do not have the tool immediately, you are losing time. The longer the time you lose, the more difficult it is to fish the thing.
And if you don't know what's down there,
Yes, that's the other thing.
worse.
Okay, now here I've shown you something called ton-mile calculation. The ton-mile calculation is done. You know, there is those who have seen the drilling rig, there is a line that goes over the drilling rig and comes down to the drawworks. That is the one that goes in. As you go deeper, it goes deeper. Okay? Now that is the one on top of which the whole weight of the string is hanging. We normally do cut and slip of that, you know, or if I have to talk in simple terms of those who are not drilling, you know, you take your car for service after how many miles? 5,000 or 1,500, depending on different cars, right? So, and suppose your speedometer is not working, how do you know how many kilometers you have traveled? Do you understand my concept? If your speedometer is working, you know how many kilometers this vehicle has traveled. Then you can take it for the right service. So the same way, here, this is what we do, a ton-mile calculation. So we do this calculation so that after so many miles, I have to cut this. But if you are not doing your calculations, you do not know when to cut. And what happens sometimes if you do not do it right time, this string breaks off and it falls down the hole. Now, here is something, especially in terms of your rotary equipment. Your string is going up and down. At the same time, the string is rotating also. It is very crucial to note that, because when you start having problems like fishing or stuck pipe, right? It will not hold you first. You're drilling nicely. Suddenly, when you come to formations that are very tight or sticky, it starts to make rotation a little bit difficult. Then finally it holds you. So that is where your rotary equipment, you make sure they are maintained properly, and also they are being monitored properly. Because if you know the torque is going higher, that means you know something is wrong down below, if not on surface. Same way you've got when you have top drive. You know, like normally the old ones used to be rotating. Nowadays you have the top drive, so it's rotating from the top. But the same principle applies there. Make sure that your calibrations are done properly. And that is where, you know, as regulators, you normally can get the feedback in terms of charts from them. So that becomes your record, that they have done this work. Then there is, when you are generator, okay? Generator capacity to run the entire rig load. This is something I would just like to spend a few minutes. How does your rig work? It uses a generator to run. It uses diesel, right? Now sometimes you have, when you are drilling, you have the rig powered trips, am I right? The generator trips and generator fails or stops working. Then the guy has to go and start the second generator, because sometimes it is taking too much of load. That is why, make sure, if I want to go to a depth of 2,000 meters, it tells you how much of horsepower I need. Make sure your generators are there enough so that you can cover the amount of load that it can take and the power that it requires. Because otherwise, you're almost trying to push. Imagine if one of your marathon runners were running and he has got only one leg and the other leg he had a problem, so he can only run with half a leg. So you can't go too far for that person to complete the marathon. Am I right? Same thing happens is, if you have generators, imagine that plan on the depth you're going to drill so that you've got enough of generator capacity available, so that you've got enough of power to move things. What all does the generator move? you've got the rig, the hook load, you've got the mud pumps, you've got the boosters if you're drilling with power. All those things have to run on this. Air, your fluid agitation, all these things run on the power that's supplied. So make sure you've got enough of it to supply. Then you have the main generators. At the same time, you always have backup generators. These backup supplies are mainly for a few things. Imagine if you're drilling and the power goes off and the backup is not on the lights. What will happen? Your whole rig site is in total darkness. That is why at least your backup supply should include power lighting on the rig, so that in case it's dark also, you can still fish, move up or down. Then the second thing.
And also, you have pumps for your water. You
Yes.
definitely do not want to run out of water. So, you know, the backup equipment that you need, or backup generation you need, has both on-site and off-site. Very often your pumps and things for your water are off-site, but they have to be maintained, and you have to have the same type of backup for those as you have for every piece of equipment on-site.
And the last thing, if you saw that first film that I showed you, if the blowout preventer cannot close your rig, close your well, the well will come alive. So that's why even the backup equipment should be actually linked up to that, so that if the main power supply goes off, still it can switch to this one, and if you want to close the well, you can close the well. So please make sure those who are, and I think so this goes across all your different equipments that you use, even if it's a geophysical or other services, please have backup when it is required. It may be a small extra cost, but what you're saving is time and precious money that you would have lost if that backup was not there. Very crucial. One of the reasons being, we do not live in our countries in East Africa, we do not have much of services available locally. You know, it's like if you're in California or something, I can call up and in 4 hours time I can get a backup for that equipment there. But we do not have that luxury over here. Everything, your closest point is probably Dubai. That is why make sure you've got backup. Now, the next piece of equipment that is very crucial for your rig and for your activities is the cementing unit. What we do here is, for those who are not familiar with drilling operations, what we do is first, we drill a hole using a bit, okay? Once a hole is drilled, we have to run a casing inside that hole. So now the casing goes there, and now there is a small gap between the casing and the hole. So that cement has to be pumped to hold this casing in place. Now, why is this very important? This is very important because what is flowing from that well? What is coming up?
Steam.
Steam. What is the temperature expected?
More than 200.
200, okay? When you are expecting 200 degrees of steam flowing through that 24 hours a day, 7 days a week, 365 days a year for the next 25 years, what's going to happen to this? The casing is actually made of steel. What is going to happen to the casing? It's going to expand first, right? How much do you think it expands? Let me give you a simple example. I've done this. I did not believe this first, but I saw it and then I believed it. We finished one of the wells in Hawaii, and everybody told me, Sam, it goes 2 feet. A casing, a cement, a steel going 2 feet. I didn't believe it first. Next day morning, when I actually tied a small rope to that and came back, that valve had gone up about 2 feet. So what has happened is, this whole casing has been elongated because of what? Thermal expansion, temperature, right? So now imagine, after you put the cement, what is going to happen to this case? It's still trying to expand, right? Now that is where you have to make sure your cementing is done properly. Otherwise, it starts developing cracks, and then other fluids from the sides come into the well or into the casing, and they can actually eat away the casing. You know, when I talk of eating away casing, you know, you drink Coca-Cola, right? Or Coke. Have you ever tried this? There is a video, you can see it on YouTube. You know, you eat chicken, right? You have chicken bones. You take a Coke, you put a few chicken bones into that, and come back after 3 or 4 days, the chicken bones will be gone. They dissolve in that Coke. Same thing happens to the casing when it comes in contact with things like, you know, we are talking about hydrogen sulfide, carbon dioxide. When carbon dioxide comes in contact with steel, and when it reacts, or even hydrogen sulfide, it actually causes the casing to crack or become brittle. So that's why we have to be very careful of how we do the cementing. Now cementing again, you cannot do it the way cementing is done in somewhere in Addis. You have seen the cementing done, right, George? I think George was telling me the other day, he doesn't want to be here at the next earthquake or something. Because the cement quality that we do is different. Because what happens if you have seen the cementing guy here, he's mixing 1 bucket of cement, pours it into that, then he again goes and mixes a second batch of cement. So what happens to that? Are the 2 batches the same? No. We cannot have that happen in a geothermal well. Because if that happens, there is a difference in quality and cracks can take place. That's why it's very crucial to maintain that. And then you have to be these parameters have to be monitored very closely. Because if you see on the drilling rig when the cementing happens, it may be going on for 8 hours or something, sometimes continuous. Am I right? So there you have to make sure the cement is done properly, pressures are maintained, and then it comes back to surface. So that's why all those things have to be monitored properly, and the data should be stored. Now why should that data be stored? If I'm doing cementing on LR9, why do I need the data to be stored? What will I use it for?
Just lesson learned from the first
And
next one.
for the next one. Thank you. On the next one, you can probably learn from what you have done on cementing on this. If you want to make some changes or make improvements, you can use this as a stepping stone. But that is why it's very crucial to maintain records. Also, he had mentioned about going back into the same well later, because sometimes you have to go and clean the well. If you do not have records properly, sometimes if my record does not show that there is this problem, there is this thing in the well, next time I'm going in, I'm going to push something through this, thinking that this diameter is bigger. Will it go through? No, because this is not recorded. Nobody told me that here it is smaller. So if I run the same thing here, will it go inside? Are you getting me?
Sam, from a regulatory standpoint, what do they need to know about the cementing job?
Okay, from a regulatory standpoint of view, first thing is the type of cement used. Because different types of cements have different characteristics. What is the density of the cement? Then the most crucial is, was the pressure testing done? Because after you do the cement, you test it with pressure. If the pressure is maintained, that means that cement integrity is proper. If that is what, we normally give it back to the regulators also. Because the regulators sometimes are there to check it.
And also, you have to wait cement to dry.
Yes.
How long will it 24 hours, 48 hours?
That depends on the cement quality.
Yeah.
Because when you're doing a cementing, you actually have calibration done. So you do it in the lab, and that actually the same things, you follow it over here. So if in the lab it has dried up after 10 hours, maybe in the field it will dry up after 8 hours, because it may be different, or maybe a little bit longer. But depending on what you have done in the lab, you'll have to follow similar precautions.
And what about the methodology, like single method, whatever?
Okay. Now what we do is, methodology-wise, you've got different ways of doing it. Sometimes you can pump the cement through the casing. It comes up through the annulus, comes back up to surface. That's one way. Second way is actually you do the reverse. You pump in and you actually come back and you take this way. What happens here? Your hydrostatic is lower when you pump down the annulus. But be very sure it is a very tricky situation. Even if you miss a little bit of slow, you know what happens to cement, right? If you don't mix it properly, and what happens to cement? First, when you pump it, it is in a liquid form. What happens to that afterwards? Concrete. I've got some pictures, I don't have it now on. You've seen where people have pumped and have missed something somewhere. Either their equipment failed to pump it fully, they lost time trying to fix the equipment, and the cement, we call it cement setting up on you, fast set. So suddenly you've got your whole string of, you were actually pumping to push the cement out here, but now suddenly you've got this hole inside the bottle full of cement.
Yeah, that's why I was asking. When you go back to the river, you have to drill the concrete.
Yes.
So that's which one
Yeah.
is better in geothermal understanding?
You do have to be careful too about what water you use, because sometimes the drilling water can be of different quality than cement water. Cement water has to be much
Pure, yeah.
than is normal drilling water.
Main thing is the time and your equipment that you use, the quality of cement that you use. You can place it either way. This way or this way is fine. But all your equipments have to work very, very practically in a proper manner. And be very sure. You know, I sometimes give this example. If you go to see a patient who is in the ICU, you see a small monitor next to it. Would you like to see it a flat line, or would you like to see it beating? Have you seen that? You go to an intensive care unit, ICU. What do you call when a patient is very serious? Huh? Yes, next to him there is a small monitor. You would like it to be very nice and straight, right? Or would you want it to be moving like this? Which would you prefer? Moving, at least moving, right? At least moving. Maybe sometimes because of his way he's breathing, it may not be the 72 that you expect from a normal human being, maybe only 60. But still, if it is moving, you are happy, right? If it is not moving, there's something wrong somewhere. Same thing happens here. When you're cementing, be very sure you have your graphs plotted very neatly. That's why I put that last one there. Your sensors have to be calibrated and in working condition.
Yeah, just to share my experience, it's not only the quality of the cementing. During cementing as well, it is the appropriateness of how you do the cementing job. For example, there were two cases in one project. One was injection well. It was drilled shallow because it is injection well. Then when the power plant started injection well, which is 160 degrees. And then what happened is because the cementing job was not properly done, because of expansion, as Sami said, it went actually not 2 feet, 1.2 meter. I could show you tomorrow if you want how actually it went up, and it has to be done some work over on it. The other thing that we faced also in another project is not the quality of the cementing. When you do the top-up job cementing, sometimes you could have water there before when you do the top-up. If there is water there trapped, and then you put cement there, then cement job is done properly, well is finished, and wait to heat up, and then the well was tested, and then the casing collapsed because there was trapped water between the two cementing jobs. And then the rig has to come and do work over, which was a huge cost for the project. So it's not only the cement quality, also the job procedure as well, checking whether you have water trapped and other things as well.
I think what Kifle touched upon is a very important topic. I'd just like to spend a couple of minutes there. when you are cementing casing, everybody knows, I am sure, how a well looks like. If you see any oil or gas well, it will be broadest at the top. As you go down, it telescopes into smaller and smaller. Is everybody clear on this? The biggest casing is on the top. As you go deeper, it's shallower and it's smaller and smaller. Now, when you come to one section, suppose I'm drilling, I've set casing here. Then I drill further, I go to next depth, and I run casing. So what happens there is, on one section, there is casing to casing at one point. And one section, there's casing and open hole. Okay? If there is only formation, that is fine. But most of the problem happens in the casing to casing section. Now, why is that? There are two metal pieces. Okay? Now imagine there is you pour a little bit of, you can try this at home. I am sure the ladies know it very well. You can try this is, you take some water and put it in a pan and close the pan from top. What happens to that water? It boils. Does the pan remain closed very soon? What happens to the pan? The top of the cover of the pan. Or the pressure cooker. What happens to the pressure cooker? Suddenly the pressure cooker blows out, right? The water was very limited, but just because of heat expansion, it blew off. Same thing happens what he was just talking. If your cementing is not done properly, or if top job is not done properly, the water that's trapped between the casing to casing expands, and it will not go here, because this side there's the formation or mud or earth. Where will it come inside? It's going to come inside the well, because that is empty or there is steam. Once it comes in, it actually collapses the casing, and sometimes you find casings like this, or even gone through. That's why it's very crucial. So here is again what Gordon touched upon. One is water supply. Make sure you've got enough of water to do your whole casing cement job. If not, do not start the job again. You do not have time to stop the job halfway through, go and look for water to fill it up. Number one. Number two, have dedicated lines for mixing and pumping. And then I've left there safety links. Also, what I put there in red is the piping manifold. I'll show you that on the next one. You see here, these are the piping manifolds. So what you see here is cement gets pumped from the cementing truck through these, and they go up the rig. Now, these pipelines are seeing pressures of more than 4,000 to 3,000 psi of pressure. That is why we always make sure that if the pipeline is here, we always make sure that we've got safety links, that even if they break, it will not hit anybody. Otherwise, it's more like a whiplash, and people have got killed because of the piping coming apart. Then, quality control. That's what helps to avoid different other problems. But these are things that have to be made sure. And one thing to be very sure, I'm going to do cementing on a new rig site or a new job. I've done the cement before. When you come to the cementing site, what will you do to the pipelines that are empty? What do you do normally? Make sure to pump fluid through this, at least water, to make sure this is clean. Because even if a small amount of cement starts getting stuck onto the inner sides of the pipe, very soon it becomes a big clog. And sometimes you see how our toilets get clogged. The same thing happens there, and everything gets messed up. So make sure your pipelines are clean before you pump. I did touch upon the fluid system, so I won't go much. But there, I would like to touch upon three things there. One is the mud cooler. The mud cooler is this piece of equipment here. What does the mud cooler do? When the mud is going in the hole, it is at normal temperature. It goes to a depth of the bottom of the hole and comes up. What happens to the mud temperature? It increases. Now, if the mud temperature or hot mud goes through our pumps, what will happen to the pump valves? It will get damaged. That is why before you pump the mud back into your system, you have to cool it. Make very sure that if the temperature goes about 60 degrees, have your mud coolers running. Because otherwise, your pumps will get affected and all other things get messed up.
Sam, could you spend just a little bit of time on mud engineering and cement engineering in terms of the use of additives and retarders and things like that?
Okay. Now, when I told about mud, what is mud? It is bentonite or clay. Simple is clay. That is the basic constitution of mud. But we add a lot of things to that to take care of different things. Like, remember we were talking about lost circulation. How do you fight lost circulation? You sometimes pump things like sugarcane, molasses, the bagasse. So what happens there? It goes and packs across the lost zones, seals it, and you can drill further. Then you sometimes have high temperature. You know, because of high temperature, the property of this mud may change. So what you do, you add high temperature additives to maintain the quality of the mud. Then, one of the things, remember Baran was telling, she goes to the shakers to pick up what? Cuttings, right? How do the cuttings come up? Because this mud is not just water. It has the capacity to pick up the cuttings as it comes to surface. And then it comes to the shakers where it is sort of like a sieve. The fluid goes back, and the cuttings are collected by the geologist to study it. Okay? Now, imagine if the mud was not thick enough, this cutting will come up and then drop back again. But we should have good cuttings, so capacity of carrying. So we have got gel strength increasers, so they carry the cement up, these cuttings to surface and drop it off. So these are a few of the examples of additives that you use to mud to keep the properties. Now, this mud also is kept in agitation always. So you've got agitators in the pits, because if the mud is just sitting in a pit, it will all settle down. So you actually keep it in motion always so that it keeps agitated. That is for mud. Now for cement. Sometimes when we are drilling with cement, you hit losses. Okay? When you have losses, the cement will not come back to surface. So sometimes what we do, we have to reduce the weight of the cement. So we actually mix nitrogen with that, or air. Then, when we do cementing in lost circulation zones, we will pump a spacer. So what the spacer does is, if there is this lost zone here, when I'm pumping cement, it comes here, and the spacer sort of expands. So it sort of forms a wall against this lost circulation zone. Cement can come and patch it up. Then you've got cementing additives like thickening. Now suppose you are drilling in a hole which is very hot. What would you like to do to the cement? You would want it to slow down heating, right? Otherwise what will happen? The cement will fast set. So you have retarders. So if you had a retarder, like a retarder is what we do for, like a sugar is a retarder. So if you put sugar in the cement, it will take long time to set. But if you put salt in the cement, it will set harder, faster. So those are sort of the additives that we mix with cement to make sure that we have the right properties for the cement that we use. Then one of the things is the flow lines. As the cement or the mud is coming back, sometimes the mud is mixed with air so that you are fighting loss. When it comes to surface, it expands, or it also has H2S. So what you want to do, you want to remove the H2S, but you want the fluids to go back into the system. So you've got separators that remove the air and the fluid goes back. One of the things there to be very clear is your gas detection systems. I've got a slide later, so I won't touch upon that much, but all along these pits, that is the place where the fluid from the well first comes to the surface. Please have your gas detection equipments working properly. Why I said working properly is, installing a gas detection system, as George touched upon earlier, we have seen some places, this is a gas detection instrument. It is there, but if it has to work, it has to be connected to a power cable. Just for the sake of the regulator, I put this. Oh, regulator came and saw it, he is happy. But is it connected? No. Will it work? No. Will it save your life? No. Why are these detection equipment for? It is to save your life and to save others' lives also.
I think one thing that we probably don't stress enough is that everyone on the drill site has a safety responsibility. If you are the lowest man on the team, if you see that something's missing, you need to report it and it needs to get fixed. Don't just think, okay, it's not my responsibility because that's the safety officer's responsibility, or it's not my responsibility because that's the manager's responsibility. Point out things that are safety omissions or problems or potential problems, because that's where you'll save both time and money and lives.
What Gordon touched upon there in modern day terms nowadays on the rig, we call something called stop work permits. The stop work, STOP permit, everybody and anybody on the rig has the right to use that. If you are as he said, if you are the drilling manager or if you are the cook in the kitchen, you are walking onto the drill site and you find something not right, please stop that work. Fix the problem, then continue.
Yeah, I've got a very good friend, and he was in the U.S. Navy, and he was stationed down in San Diego at a naval base that had a lot of nuclear equipment. He was just, he wasn't the cook, but he was not very far above the cook. He shut down the entire base for several days because he detected a potential nuclear
leak
problem.
And here, it does not matter who you are on that rig site. The most crucial thing is safety. Now, why do I say on this point of safety? Because, now let me throw you another jinx in this. You saw this leak over here. You did not pay attention. You walked away from it. Next day, this leak that was here so much has now become such a big leak, or a big, whatever it is. You are the same person who got up the next day morning for the shift and came across it. Who is going to die? Me. Who is responsible? Me. So in other words, I am responsible for my own safety. Also, I'm responsible for safety of others, safety of the equipments, and safety of the environment. That is why, please, one of the things to take away from this is, do not take safety lightly. I cannot stress on this because time and again you find incidents happening, and sometimes even after you take all precautions, things happen. So imagine if you had not taken precautions. 10 minutes? Okay. I think we touched upon this. Yes. Uh-huh.
You say you will have stop work permit.
Yes.
But this side effect also on the project.
Uh-huh.
When you stop your work,
Yes.
the well will be done, or you are going to die. What is the case in the case of cost, like standing the cost?
My dear friend, there is no cost to a human life. Can you pay for yourself if you are dead? You better look at that. Sorry about that.
But there is a stress on to decide on this, on something.
No, there is no stress. Let me make this very straight. You are walking across a pipe, okay? You see that this pipe has a leak. That's what he just now told you. This cook, or whoever it was, saw the smallest leak in a pipe. Imagine if he had not spotted that. In terms of this, there is no cost. Cost is the least concern. Safety first. Put this in your head if you have not put it in. Please, whoever is sitting here, safety first. Cost of life, if you can replace yourself, I'll show you a picture. I've got one picture. Let me, since you're there, let me show you one picture of what it was. Then it'll explain to you what I've been talking about. Where's that? Okay. See it for yourself. Does it shout at you all? Wish your grandson or granddaughter had a, you want to give this to your granddaughter, right? Or grandson? Just because you did not stop work, by God's grace, I've been working in the industry for 25 years on the rig. I'm sure there's not any drilling people here? Very few people you'll find with 5. Many times you'll find drillers with what? 4.5, 3.5. And these are senior people, right? That's why if you, these things do not come with any spare parts. So the cost of stopping that, sorry my dear friend, I cannot put a number to that. I do not care. But this can be, and that is now where regulations come. Now if you think of the other side, that's where the regulator comes, that he makes sure that this piece of equipment does not start without proper quality checks. But some things happen. As it is running, things happen. So when those things happen, what do? You stop your work, make sure that is fixed, then continue. There is no ifs and buts to stopping work.
Yeah, but there is a risk as well. Stopping operation also there is some risk.
That risk, can you give me a cost for that person's hand? No.
It's comparable.
Yeah. It's not, there's no comparison to human life. Because if you know, some of the insurances that have been paid out by oil companies and other companies to fix small things that could have been fixed first, you know that again, the Macondo blowout that I showed you, had that could have been fixed for 1 hour of stoppage. 1 hour of stoppage could have fixed that. Today what has happened? You can, if you have ever get a chance, as you go home today, just check what has been the cost of the Macondo blowout to BP. You'll see, tomorrow you tell me the numbers. Then you can tell me what did 1 hour cost them. That's what it is. Thank you very much.
Yes, thank you.